Well, my friend Elizabeth brought her cat with her, and so let me pet that cat. Oh, guess I petted it a little too hard. Well, anyway, combining functions. We can find sum, difference, product, quotient, and compose functions of two variables, and they're all defined in the usual ways. I don't know if I need to bore you with this because you would guess that they're the way that they are. One little concern is don't divide by 0, of course, but f of g of x is just what you would expect it to be. And so all of these combinations of functions can be easily done. So here's another question. Give the domain, range, and a sketch of this function of two variables. Aha, the sketch is the tricky part. But I think we could probably manage it. The domain, we know that 16 minus 4x squared minus y squared has to be positive. So 16 has to be greater than, 4x squared, let me make that plus y squared, because we can't have a negative under the radical. 0 is all right. So the domain is the inside and boundary, since equal to 16 is okay, inside and the boundary of the ellipse, and here would be the ellipse if you took this equation, made an equation out of it, and then divide both sides by 16, you get x squared over 4 plus y squared over 16 equals 1. So the domain is the inside and the boundary of that ellipse. So, and the range, well, since it's a square root, we could say the smallest this could be would be if 16 was equal to that, so then we get the square root of 0. And the largest it could be would be when we don't subtract anything from 16, so that would be when x and y are both 0, so square root of 4. So the range of this is numbers between 0 and 4. So the range is numbers between and including 0 and 4. I think you can see it right here. Note the graph is just the top half of the ellipsoid, and it's this ellipsoid. By the way, how do I know that? Because if you squared z here and then square this, you get z squared equals 16 minus 4x squared minus y squared. Take that equation, add the 4x squared and the y squared to both sides, and then divide by 16, and you would get this ellipse. So, of course, squared both sides. When I squared both sides, I introduced, this could have been plus or minus, so I introduced also the bottom half of this ellipsoid, but that's not actually, the bottom half isn't really part of the function. I confess MathCAD won't draw that in that current state, and you could probably imagine why it won't, because it is too afraid of running into square root of a negative, so it won't attempt to draw that very well. But I flipped it over into what's called spherical coordinates, and that might be familiar with you from, I guess it was Unit 1. And if I flipped it over into spherical coordinates, I hope you remember, this is r cosine theta, this is r sine theta, and this is r cosine theta for the z. And so here's our picture, and granted, I want you to notice something. I can't draw this any other way. I can't restrict my z values, so if I could, I'd cut this thing off right here at 0. So it's really only the upper half of this odd looking, what does it look like? Looks like a pill, right? It looks like a Motrin or something like that. And I actually took a better picture of that, but I can't rotate this one anymore. But that's what the function is. The function is this surface. And so there's the graph. So note each of these horizontal stripes that goes around here is what's called a level curve, and more on level curves in the next video.